today we are looking at introduction to database design. So the first question would be, what's a database? Yeah, so I won't give a textbook answer, but a database is a place where we store our data. It's that simple. So a place we store our data, that's what I would call a database. So in the past, people used to use spreadsheets for their data, and we know spreadsheets from Microsoft Excel. Yeah, so to date, some organizations still use that. So let me not call them organizations. Let me say some people still use Excel for their databases. Yeah, so today we are going to look at databases, the design part. That's why I say the requirements are a pen and a paper. So there was the requirements won't be a lot of I don't know, a laptop, MySQL installed. We'll do that in a different session. So today it's a day of the design, because let me give an example of why the design is important. Because I always give an example of Google. Yeah, so we all have our emails. For example, mine is chegejohn15 database design. The reason why the requirements were pen and a paper is because when you're talking about the design, it's not a matter of the development. It's a matter of how you lay out the structure from where you now have to come and then have the data inserted. So that's what I was saying. Some people opt for options like Excel, which I don't think I would call it a database, but it would still store data, and people can share it if with a very small organization. That would work. Access would also work, and now from the access part, since it's a relational database, then we'll then have relationships. So I was saying the importance of the database design. I always give an example of Google. Yeah, so for example, we have our Google emails. For example, mine is chegejohn159@gmail.com. So when I was getting that email address, I went to Google and asked for chegejohn@gmail.com. Then I was told, we can't give you that one. There is someone with that email. So let's assume when Google was creating the database for storing the emails, they messed somewhere in the design. So that will, and then tomorrow they would tell us in the morning, by the way, can you get your emails again, simply because there was a change in the design. And now, since the simplest thing for us to create a new design was to drop the database and then recreate it again. So tomorrow morning, everyone get ready and let's get new email addresses. I would wake up very early to get the chegejohn@gmail.com. Yeah. So that would bring about a lot of confusion, because people know me as chegejohn159. So when they'll be sending emails to chegejohn@gmail.com, they might be sending to someone else, then I receive the emails. So you can see the confusion that can come along with a wrong database design. That's why it's core to understand how databases are designed, or how best to design the databases to avoid such a situation. It's not the best. Yeah. So yeah, those are my contact information. I'll share the slides. So when we talk of databases, we can't fail to talk about SQL. Yeah, so when we are talking about the relational databases, yeah, so SQL is a database, a language to speak to the database. As I've simply put it, SQL is simply a programming nomenclature used to access and manipulate databases. This simply means SQL is used by computers to understand, to communicate with the database. So, and also from the SQL, you can do an insert, an update, a delete. You can create new databases, create tables. Also, you can retrieve data from databases. Yeah. So, yeah. So when we talk about the database design, yeah, the most I'll call it technical, if not confusing, part is the normalization. Things called the normal forms. Yeah, so as I have simply put it here, normalization is the process of making a database normal. And I've written there, normal means you are doing as expected. Because if, for example, you go into the market and they do some things that are not whatever people have are used to seeing, they'll consider you abnormal. So a database that does not conform to the rules is not normal. If databases had a market, that database would be the madman in the market. Yeah. So we have okay. I've said we have three normal forms. That is, I would say it's partly true, partly false. Yeah, so it's true because by the time we have a database normalized to the third normal form, that is, the database is good enough in terms of redundancy and consistency. But we have other forms. We have the fourth, fifth, sixth, I think to the seventh normal form. But anyone going past the third normal form, I don't know whether it is it would be okay to call it show off, because by the third normal form, you already have a normal database, a database that behaves as expected by the other databases, as I said, in the market. Yeah. So when we talk about the first normal form, it has rules. And the rules are as simple as you must define the data items. As always, we are storing things in a database. So what are these items you are storing? These are the data items I'm talking about. So the second rule simply means ensure that the data is atomic. Atomicity simply means, yeah, the intersection of a row and a column only carries one value. So the third rule, create a primary key for each table. We will come back to the atomic rule with an example. Yes, so the second normal form says that the database should meet all the rules of the the first normal form, as from the previous slide. Yeah, so and also there must be no partial dependencies of any of the columns on the primary key. Yeah, so that might sound technical. This might sound a bit technical when because someone might ask, what do you mean partial dependencies or of any of the columns on the primary key? Okay, let me give an example. So we have a customers table. When we are talking of maybe e-commerce, let's talk of Jumia. If you have a customers table, then then we have a customer, the name, the ID, and in the same table, let's say we have the purchases, whatever the customer purchased. That would not make a lot of sense because to the second normal form, because there is partial dependencies of the columns on the primary key. Because if the primary key is the customer ID, whatever the customer purchased, there is no direct connection with the customer, whatever they purchased. So that's what we are talking of, partial dependencies of any columns on the primary key. I hope that's clear. Someone?
Yes, sure.
So that's clear, right? Okay, so when you talk of that normal form, yeah, it has two conditions, or let me call them rules. So it must be in the second normal form first, then all non-primary fields must or are dependent on the primary key. So this is an example in most of the text, is an example of, for example, Anto is from Nanyuki. Yeah, so when we are creating an Anto's address, we can have the town, the address, and maybe, so for us to come up with another, maybe a code, an address in the town. So when we talk, we see those three columns. If they are in a table, we can see that they depend on each other more than they depend on Antor. So that would simply mean these non-primary fields are dependent on each other than being dependent on the primary key. So in that case, for us to go to the third normal form, we will have to remove those three fields, put them on their own table, and maybe call it, I see in the US they call it a zip, then have a zip table. Then we can then connect and talk to this zip, someone else the same zip. For example, because you can see there must be someone else from Nanyuki here. Yeah, so if there are other people in Nanyuki other than Anto, they can use that as their zip. So do you people get what we are talking about, or what we mean by the normal forms?
And if someone has a question, you can drop it on the chat so that we can see it.
So far so good. Okay, thank you. So next we will look at the database relationships. This is the SQL database relationships. Yeah, so when we are talking about relationships, the association between tables. Yeah, so there are three types of relationships when it comes to relational databases. We have one-to-one, one-to-many, and many-to-many. So let's start with one-to-one. So not very common. In most cases, it is ignored or removed. I'll give two examples of one-to-one, and an example that we don't need it, and an example that would force us to model the same. Yeah. So let's say, for example, like I've said here, for example, a student has one-to-one relationship with admission number. So instead of having a table for admission numbers and a table for students, then have a relationship using a foreign key to connect these two tables, we can just use the admission number as the primary key. So do you see now, when you have a one-to-one relationship, if there is no any other information about whatever has for example, the admission number does not have any other information other than the admission number. So if you were to have a table of admission numbers, it would be maybe the primary key, the ID, and not the admission number. So if there is not any other information about that admission number we want to store, then we don't have to have that relationship. We can just ignore it or add it as one of the columns in the students table. But when we look at the relatable situation down there of a lab technician, so in most institutions, a single lab is assigned a single lab technician. So it's a one-to-one relationship. But now, from here, we can't say that we can just use the lab as the ID or the primary key of the lab technicians or the employees table, you see. So, and also we can't have the technician as one of the columns in the labs table, because we need a lot of data about the lab, in terms of maybe if it's a computer lab, the number of computers, the number of chairs, the number of whiteboards. Yeah, so for example, we need such information. So you see, now we need some information about the lab, and also the technician. We need, if for example we have only a database of technicians at labs, we need at least the first name, second name, at least the information about the technician, the phone number, the ID. Yeah, so do you see now, in that situation, we will be forced to have a one-to-one relationship. Yeah, so, but in most cases, a one-to-one relationship, they don't happen much. Because if I was to start a school, I would assign a certain technician different labs. Yeah, because so that I can see value for my money. There's something called return on investment. So let's talk of yeah. So I said that we'll come and explain what I meant by atomicity in the beginning. Yeah. So these are an example given from here. So we are saying tables need a primary key. These are field in which uniquely identifies each row in a database. I hope that's clear. So the intersection of a row and a column must carry an atomic value. This means you cannot store, for example, Benson Macau or John Shege, but you can instead break it to something like the table below. So first name and last name. So this was an attempt to explain what we mean by atomicity. So yeah, so this is what we meant by being atomic. Yeah. So let's talk of the most common and the most confusing database relationship. It's the most common, most used, and you'll find it in very many situations. So we call it one-to-many. So, and in a one-to-many relationship, one record in a table can be associated with one or more records in another table. For example, we are talking of, there's an example given in this slide of a customer having many sale orders. Yeah, so you're not limited to how many TVs you can buy in Jumia, yeah? Yeah, so you can have a one-to-many relationship with the TVs or whatever they are calling the sales orders. So for us so we can't talk of one-to-many relationship without mentioning a foreign key, and we'll give an example of these. Yeah, a full example. So when we talk of a foreign key, so as it's explained from here, a foreign key is a field in one table that refers to the primary key in another table. The table containing the primary key is called the child table, and the table containing the primary key is called the referenced or the parent table. So I hope that's clear, because it's simply explaining what's a foreign key. Yeah, it's a column in a table that is a primary key in another table. We'll have an example of the same, so it will be clear. So we are still on one-to-many. So the primary key of the many side becomes the foreign key in the one side of the relationship. So for example, we can see we have a voting center and a voters table. We are assuming a voting center can have many voters, but a voter can only vote from one voting center, yeah, no matter the country. Yeah. So for example, we can see that we have a voting center, Busia, Machakos, and Nairobi, 117B, 09 AM and 116W. Then we have the voters. Yeah, so we have those voters. Okay, those are ID numbers are not real, so you can't use them for any purposes. For example, my admission number is not, my ID, sorry, is not that one. Yeah? So we are saying that when you have a voters ID, the center table and the voters table, so what we can see that there is a one-to-many relation between the voting center and the voters. So we have said the primary key of the many side, the voting center is the side that has many voters. So the primary key of that table, voting center, will be the foreign key in the table, voters table, as you can see in the explanation or the slide on the screen. It's very clear from there. I hope we are good to go. Okay, we are still on the one-to-many relationships. So we are saying a one-to-many relationship is a database that is the most in the relational databases, as I said earlier, and it is at the heart of a good design. So consider the relationship between a teacher and the courses they teach. Let us now model this. You're assuming a teacher can teach multiple courses, but a course can have only one teacher. Yeah. So as we can see from here, it is we are saying we have a teacher ID, a teacher name, and a course. So teacher 1, teacher 2, teacher 3 with the courses they teach. So we can see that so this is also, as we try to model, we will try to look at what if they didn't follow this, what would happen. So we can see that what if Carmen teaches 2 or more courses. So we have Carmen there, you can see they are teaching biology and math. And from the first normal form, we said that the intersection of a row and a column should carry an atomic value. So we can see that the course Carmen teaches, that the intersection of a row and a column does not carry an atomic value, but carries biology, maths. So that simply means it is breaking the first normal form. So just imagine you're breaking the first law. Maybe maybe you have been given a list of 50 rules. If you break the first one, in most cases you'll not be forgiven. The 30th one, whoever wrote the rules might not have read it even himself. So you might be lucky, but you can see that they are breaking the first law of the first normal form on the atomicity. So you can see that it makes it difficult to search for data. It is inflexible. It can resort to problems later on insert, edit, and delete. So I hope that's clear. So another alternative we might decide. So let's have Carmen create another record. So these adheres to the first normal form, that's true. But now the second normal form is violated because we can see there is redundancy, for example, in the ID. And also it is violating the first normal form of the primary key, although we can maybe have another extra column of ID. So you see now that we have decided for this table we'll have a teacher ID. Then we start creating another ID. So you see there will be some inconsistency and some redundancy. Yeah, so this option for sure, every intersection of a row and a column is atomic. So we are adhering to the first normal form. But again, we have a lot of redundancy. For example, teacher 001, teacher 002 in the ID. So that defiles the second normal form. Yeah. So faced with such a situation, this is what we should do. To implement a one-to-many relationship in the teachers and the courses table, we break the tables into 2 and link them using a foreign key. For example, we have removed the courses column in the teachers table. So we have only the teacher ID and the teacher name. So that's the information about the teacher. So then we have a courses table where we will have the course ID, the course name, and the teacher ID. Now the teacher ID is the foreign key, which is a primary key in the teachers table. I hope that's clear for everyone. So now this is where the okay, are we together up to there? By clear I mean we are good, or is the information too much? Okay, thank you very much. So when I said the requirements were pen and a paper, what I meant is we will use them when we get to the many-to-many relationships. Yeah, so this is the only slide about many-to-many relationships. And this will now explain the advantages of joining the meeting. Because for someone to understand a many-to-many relationship, you must do it yourself. So this is in this slide, there will be a lot of talking a lot of questions might be asked, and I might so table, a third table. Can I get one volunteer? Yeah. So in this student table, we will have the primary key, the ID. We will have the student ID and the unit ID. So we will have a third table introduced. Then what we will do, we will say ID number. Let's go back to the unit and say George does maths and physics. Yeah, he is wise. So Bill, let's say for Bill, he does maths and Swahili. Yeah? Maths and Swahili. Yeah. Anto is a science student. He can do biology and physics. Biology, physics. After all, it's what he does, biology and physics. The Shege can do English and Swahili. Yeah, because my languages are good, as you can hear from the call. So anyway, so if this is the case we are talking about, when we model the student units, then if we have the ID number 1 or the primary key number 1, we will have student ID number 1 doing unit number 1. That is George Maths. Then we will have student number 1, no, the ID number 2, the primary key number 2. We will have the student number 1 doing number 5. That is George doing physics. Then we will go to ID number 3. Number 3, that will have student number 2 being Bill doing 1. That's maths. Then we will have number 4 as Bill doing Swahili, that is 3. Are we clear? So if told to continue and fill that table, do you understand now what we mean by many-to-many relationship? Yeah. Exactly. So the members, Sabi, is that clear?
Yes, clear.
Anto, is it clear?
Just a moment, Shege. I'm looking for a tool that can maybe illustrate what you're talking about.
Okay.
I'm sharing the screen now.
Okay, please do.
Can you see my screen?
Yes.
Which screen are you seeing?
The users, the countries, order items.
Okay. So now we can model what you are saying directly, and we see what you're talking about.
Exactly. Yeah.
We had students, yes.
Yes.
So students were, how many students were there?
We had 4 students.
4 students.
Yes.
Okay. Just a moment. So we had you talked about 4 students. There was a courses column as well. Yes.
No. We had two tables.
Yeah, 2 tables.
Students and units.
Okay. Just a moment. So we had 2 tables.
Yes.
Students
and units.
Yes.
Each with 2 columns.
For the units or for the students?
Both. Each. Both the columns are ID and name.
ID and name.
We are starting in. So for the students, we had ID1 as George, ID2 as Bill, ID3 as Anto, ID4 as Shege.
So there was George.
So
there was
Bill,
Bill.
let's assume when data when and Shege. Then for the unit, we had 1 to 5. We had maths, English, Swahili, biology, then physics.
Yeah.
Is that okay?
Yeah, that's okay.
So also somewhere, not necessarily in the databases.
Yeah, there's a pivot table.
No, I'm saying somewhere, although not in the databases, you can note that George is doing math and physics.
Okay, so George is doing math and physics.
Yeah, so
one is doing math and physics.
So I'm saying, have this information somewhere so that when we are modeling.
Oh yeah.
Exactly, that's what I mean. So George is doing math and physics.
Yeah.
Bill is doing math and Swahili.
Math and Swahili.
Anto is doing biology and physics. They said he's a science student.
Yeah.
And Shege is doing English and Swahili.
English and Swahili.
Yes. Is that okay?
That's okay.
Now, okay, now you can now present so that we can fill the pivot table together.
You can go. I'll be modeling it right now. I'm inputting this data you've just given me.
Okay, input the data so that we can do the pivot table, yeah?
Yeah. Meanwhile, you can continue.
Yeah, okay. So as we wait for Anto to do the demonstration on the many-to-many, yeah, so we have the last slide. And the last slide we are talking of, not the end. We have this one. So as the poster was saying, we were to talk about both SQL and NoSQL. So we've spent a lot of time talking about SQL. And now the last point is on NoSQL. So someone was saying there's some organizations asking for SQL experience, and now since they don't know SQL and the organization was asking for NoSQL, so they thought they have the qualifications, because they were saying, after all, I don't have SQL qualification. So they thought that's what we mean by NoSQL. So when we're talking about NoSQL, so it doesn't mean we don't need SQL. It means not only SQL. In short, there's something more than what SQL offers. And what NoSQL offers is something, and you can see I've put in quotes, schemaless. So whatever we have been doing from the beginning, it was modeling the schema. The schema is the database structure where we were saying, okay, we need a table with 2 columns so that we can store the first name, second name, third name. That's the rules of SQL. The first rule of the first normal rule, it was like define the data items. Let's know what you want to store. That is the language SQL speaks. So you must tell us what do you want to store in us, the SQL. That's what it would say. But NoSQL says store anything, we are good to go. That's the difference in SQL and NoSQL. So the reason why I've put schemaless in quotes is because we can't say that we don't need a schema. So, for example, when we are developing Android, and some people like to use Firebase as the database for Android. There may be the Firebase Firestore or the real-time database. Although Firestore is now the real NoSQL. You can feel interacting with the NoSQL. So when you're doing a Firebase project, So let's say, for example, you are selling clothes. For example, if I come to your website, for me to buy a dress, okay, a t-shirt, I would maybe need to see the photo of the t-shirt, maybe the cost of the t-shirt, the details of the t-shirt. When I go to the trouser, I expect the same data. When I go to a shoe, I expect the same data. Although it's a NoSQL database, we can already see there is some liking with people to the SQL databases, to schema databases. Schemas bring order. For example, you don't expect me to come to your site and find that the shoe doesn't have a price. Why doesn't it have a price? You know, we are using NoSQL and it's schemaless. We can do anything in the, yeah, it would agree, but now you see the users will not have the best time being in that site. They might never come back, and after all, that's why we create the website where they can come tomorrow, the day after tomorrow. Yeah. So that's why I put schemaless in quotes, simply because you need to have some sense of order. Although there is an actual schema. For example, you don't go to Firestore and tell Firestore, by the way, I'll be bringing this and this and this and this. You just go to your front end and tell it, take this to Firestore. Yeah? And Firestore is for Firebase. That's what I said. So although there is no schema, there should be order when you are developing it. So that's why I put schemaless in quotes. Yeah. So my first statement is clear. The second one I've already discussed how it's in quotes. Yeah. So when you talk of advantages of NoSQL over SQL, so you can't see my screen. Okay. You can now see my screen, eh? Okay. So when you're talking of NoSQL, I put I'm trying to say that NoSQL is schemaless, eh? But you can see the schemaless is in quotes. Yeah, so I was explaining why it's in quotes, because I'm saying when you are developing anything, you need to have some sense of uniformity. You see, so that's what you see. When users come to your website, they expect they know what they have come to see. If I see an e-commerce website, I know when I go there, I'll find things being sold. I'll find their price, their images, and their description. You see, although there is no specific schema, for example, when you use Firebase Firestore, but that's what you'll store for a certain product. So by default, that simply means you have a certain schema that you are developing. Although it's not asked for, you'll offer it for the sake of the users. So that's what I'm saying. Firestore does not, you don't go to Firestore and tell it, by the way, I'll be bringing you description, image, and the price for a product. You go to the product and tell it, go to Firestore and store this. Then Firestore would store that. If you were to decide to store anything else, Firestore would still accept it. So that on the advantages, you can see there is a lot of flexibility, yeah? And that's what I'm calling ease of integration, because you can simply integrate that database in web and also in Android. That's an example of how simple it would be to integrate. Also, scalability is possible because you see it allows for both horizontal and vertical growth. Because mostly when we talk of the SQL databases, you can't extend it too much horizontally. It won't make a lot of sense. But for NoSQL, I would say it wouldn't mind being stretched whichever side. Yeah, so when you're talking of the disadvantages, so the main also on the advantages is that whatever I talked about, you can store any data without specifically first defining the schema. Yeah? So any data can be stored that comes on whatever I was calling flexibility. Yeah, so on the disadvantages, we can see there is limited research compared to SQL. So SQL has been there for a long time. So yes, a lot of research have been done on it, a lot of modification, a lot of making it work. That's why it is very easy, and we had a lot of notes about SQL. But since there have been limited research on NoSQL, so you see now there is that would be a disadvantage. Because, for example, if I was to go to Google randomly and search something about SQL, there's possibility I'll get an answer. But about NoSQL, yeah, you might get an answer, but not maybe the answers might be very new. Yeah. So for example, you might get a 2019 answer, but for SQL, you can get answers as old as maybe 2000. Oh, okay. Yeah, so you can see. So SQL has been there for quite some time. It has stood the test of time, and it's still working. But when we are moving to big data, yeah, so it might fall short of whatever we need it to provide. Because, for example, when you talk of big data like Facebook, Twitter, so in IG, we are getting a lot of information, and in a lot of formats. We have images, posts. You can, for example, you've seen TikTok, so such. So you can't use a SQL for that. The flexibility SQL does not offer that. So that's where NoSQL would come in. So I hope I'm clear up there. So the next slide says the end. So I hope people have gotten something from the presentation. So that is the end of my presentation, and I hope I was clear.
Shege.
Yes, Anto.
Yeah, the pivot table now.
Okay, share your screen
Okay.
so that we can fill it together with the members.
Can you see my screen?
Yes, your screen is clear. Yeah?
So we have one table for students, one for units.
So now you'll create us another pivot table. Okay, you see that you may remove that arrow, because some people don't understand the arrows. They might be confusing. Yeah. So now let's create another table down there, preferably if possible. The table should.
Let's continue.
No, the student unit.
Okay, it's called student unit.
Yes.
And this one, unit?
It's called the unit, but because it's okay.
Okay, so the third table?
It's called student units.
Oh, okay, okay.
Yes, that way. It has 3 columns.
3 columns.
Yes. The first column is okay. It's 1, 2, 3, 4. The second column is the student ID. Yeah.
Student.
You see, you see, okay, you not there in this other table.
This one.
Yes.
Uh-huh.
We need another column. You see, other than ID.
Yeah.
Yes, exactly that. So we need another column.
Yes, we have another column. It contains.
It contains the unit ID.
I see. Oh, the unit ID here.
Yes.
So,
Yes.
so yeah. I get you now.
Can it be? Yeah, you are. By then we can just do that.
Yeah. So for easy referencing, I can say this. I can change these IDs because they look similar to this.
No, the IDs are okay.
Okay. Let me. Okay.
So we are saying,
Yeah.
when we talk about one-to-many relationship, this is how we do it.
Yeah.
We have the number in the table student unit.
Yes.
You can take your cursor there.
Yeah.
In the table student unit, we have the first column is the primary key, the ID.
Yeah, the ID.
Not that one, the other one.
This one.
Yes, that. The other one, not that one. The one on the left. Yes. Yes.
Can wind up.
No problem. Let's do this first. Okay. Anto,
Yes.
we have ID number 1.
Yeah.
Being student ID number 1, George. Doing unit number 1, maths.
Yeah.
We have ID number 2.
Yes, Bill, which is number 2 as well.
No. The unit number 2 would be George.
Unit number 2.
The primary key number 2 would be student 1. So remove the 2, put 1. Yes, it would be George doing number 5, physics. Doing number 5, physics.
Yeah.
Number 3 would be 2, that is Bill, doing 1, maths. Is it clear?
Yeah, I get you now.
Now the next would be Bill doing 3, Swahili.
Yeah.
The next would be Anto doing 4, biology.
So,
Anto doing 5, physics. Shege doing 3, Swahili, and English 2, and now Shege doing 3. Is it clear?
Yeah, I get you.
So that's how you model a many-to-many relationship. So the table we are creating down here, that's what we call a pivot table. I hope that's clear for everyone. And I hope we've gained. Okay. Yeah. Yeah.
Mm-hmm.
Yeah.
Yeah, Shege.
Yeah.
And Shege, and George, the one on January. When will it be? Hmm, hmm, hmm. You know, you know Maseno, you know Maseno wants us in school by 6th. Yes, you saw the memo, eh? No.
Anto,
Yes, Shege.
Anto,
Yes.
Anto.
Yeah.
Do you know this bit will be